All right, so here's experiment 2. To get ready for this experiment, I've taken my washers and I have them sitting in my ice water, my cold water. We're going to want to eventually transfer these washers from here and into our warm water, which was sitting in our calorimeter. And so to kind of make that a little bit easier, what I've done is I've taken the washers and I've just looped them through. In this case, it's a twisty tie. It could be a piece of string, but the big thing is you don't want to tie this up because we don't want to put the twisty tie or string in there itself. We want it to be able, the washers to be able to come off of this. Alternately, you can just put the washers into the water. You can dump it out into something where you capture the water and then just set them on a paper towel and let them lose a little bit of the water. But we want this transfer to be fairly quickly because we don't want the washers to warm up at all between when they leave the water and when they go into our calorimeter. As you can see, I already have the data being acquired. So my temperature probe is measuring temperature as a function of time. And so just like we did before, I want to just set the temperature probe into the cold water and just to be able to determine the temperature of what's going on in there because that will be the temperature of the washers. Now again, you want them sitting there for a fair amount of time, a good 15 minutes or so in the ice bath to make sure that they're good and cold. You don't want to just dunk them in there and then pull them right back out. Meanwhile, while that's recording the temperature, I have my warm water ready to go. And remember, this needs to be at least 70 degrees C. It could be a little bit warmer than that. That would be fine. But you want to be careful if it gets too hot that you don't burn yourself. You then are going to carefully measure, as you did before, the appropriate amount of water and put it into your calorimeter. Again, I'm obviously not measuring very carefully. You're going to do the experiment very carefully where you correctly measure the amount of water and pour it in. Make sure you don't spill like I did there. Okay. Now that I know that I have my good asymptotic, notice how constant this value is at 5.3 degrees C. I'm going to record that as the value of my cold water and my washers. I can then take my probe and I can put it into the warm water and put the lid on and let that sit for a minute so that I can record the temperature of what my warm water is. Again, as I've said, my temperature is cooler than what yours will be. You do want yours to be quite a bit warmer than what I have here. But I'm just demonstrating this for you. You can see now that I've reached kind of my consistent value, asymptotic value. It's around 47.4 degrees C. Now I'm ready to go. So just like we did before, we're going to want to work fairly quickly. I'm going to want to pull the washers out. I'm going to want to shake off any excess water that's on them. I'm actually going to tap them on the paper towel just to knock any of that excess water off because we want as little additional water. We really want just washer to go into there. I'm then going to pull the lid of my calorimeter off, dump the washers in, put the lid back on, and we're going to then see what the temperature does. Before I do all of this, I want to set my data up so that I'm actually recording the data. So I'm going to hit record, and you can again tell I'm recording because I've switched to the little dots. Now I'm going to pull my washers out. I'm going to shake off a little bit of the water. And again, I'm just tapping it off in my paper towel, but I don't want to spend too long doing that. And then I'm going to just dump my washers into my calorimeter. You can see they're all gone. And now I can watch the temperature of the water as a function of time as it goes. I'm going to let this sit for a little bit until I have reached a nice equilibrium value, which means that the water of the temperature of the water and the temperature of the water washers has reached the same amount. If you want, you can agitate it a little bit, but you want to be careful about that. And you want to make sure that your probe is, of course, sitting in the water and correctly measuring the value of the water. If you need to peek in there to make sure that I'm sitting in the water when I'm all said and done, you're good to go. And then once you have that final value, again, make sure that it's kind of reached its nice final value. You can hit stop, and you can record that final value and note what the equilibrium temperature is of your entire system. Again, make sure that your everything is nice and equilibrated, and that your temperature probe is sitting in the water and measuring the temperature of the water when you're done. You don't want to agitate this too much, but you can try to move the water around a little bit to make sure that it's being mixed well. When you're done, save your data, and then you can do the analysis to try and calculate the heat capacity of the washers.